The second section of Unit 5 will focus on the subtraction of proper fractions. It is worth noting that throughout this section, the first fraction, the minuend, will always be greater than the second fraction, the subtrahend. In Lesson 1, we will subtract fractions with like denominators concretely or pictorially. As we did with the addition of proper fractions, we will look at several models to help us visualize the process involved in subtracting fractions. In this particular lesson, we will use fraction circles or rectangles and pattern blocks to complete a subtraction calculation involving fractions with like denominators. We will examine these same two types of questions again, given a visual, determine the answer to a given subtraction calculation, and given a subtraction calculation, represented by modeling to determine the answer. Always remember to check to make sure your answer is in simplest form. And as we examine the various models, we will often consider subtraction as the idea of taking things away. For instance, if you have 8 gummy bears and I take away 3, then you will have 5 remaining. 8 subtract 3 equals 5. So let's begin with fraction circles or rectangles. In example 1, we will use the model to determine the difference. Of course, the answer you get when you subtract is called a difference. So the whole that we've been given here initially is a rectangle that has been divided into 5 equal sections, so denominator is 5. Initially, 4 of those sections have been shaded, so 4/5. And then we see this dotted oval, we see this arrow, and that indicates what we're going to take away, what we're going to subtract. And if you look inside that oval, we have 3 of those green sections that we want to get rid of. So we're going to subtract 3/5. And if I do that, if I take those away, I'm left with 1/5 still shaded. So what that means is that 4/5 take away 3/5 or subtract 3/5 equals 1/5. Example 2, we've been given a subtraction calculation and we're going to set it up and figure out the answer through modeling. And this time we're going to use a fraction circle. So what I want to do first is draw my hole with 4 equal sections and shade 3. There we go. And our calculation says to subtract or take away 1/4 or 1/4. So there we have it. The oval is drawn, or the circle in this case is drawn around 1/4, and we're going to remove it. And if we do that, what are we left with? 2/4. So 3/4 take away 1/4 equals 2/4, which of course can reduce. And either you look at it as 2 divided by 2, 4 divided by 2, greatest common factor for 2 and 4 being 2, and that will give us a half. Or if you just look at this circle, at our circle, it's pretty obvious to see that half of it now is left shaded. In our third example, we will use modeling to calculate 7/8 minus 4/8. And of course, our denominators are the same as they will be in this lesson. I'm going to use a fraction rectangle this time. So I'm going to need a rectangle split into 8 equal sections, and we're going to shade 7 initially. There we have it. My calculation tells me to subtract or take away 4/8. So I'm going to remove these four right here. You do that, what are we left with? Well, we have 3/8 remaining. So 7/8 take away 4/8 gives us 3/8, which cannot reduce. Let's have a look at some pattern blocks. Same idea. So here's our model, and we want to determine the difference. So we have 3 triangles. Every triangle, remember, is a 6. So we have 3/6. And our circle and arrow tells us that we're going to try and take away, subtract one of those. So 1/6. And if I do it, I'm left with 2 triangles, or 2/6, which I can reduce using the GCF of 2 again to 1/3. And if we think about that, that makes perfect sense with our pattern blocks because we associate what shape with the 2 triangles? That's right, a rhombus. A rhombus is a third. Example 2, we're going to calculate 2/3 subtract 1/3. So I need the whole with 2 1/3s put in it. Remember, the rhombus is a third, so I have 2 rhombi, or 2 rhombuses. My calculation says we're going to take away one of those. So I remove it, and we're left with 1 rhombus representing 1/3. So 2/3 subtract 1/3 is 1/3. Cannot reduce. And our last example, we have 5/6 minus 2/6. So let's see. I'm going to need 5/6. Well, that'll be 5 triangles. There we go. We're going to take away any 2 of those. So let's take away those 2. We remove them. And we're left with 3 triangles, meaning 3/6, which can reduce. GCF for 3 and 6 is 3, and we get half. 3/6 is a half. And once again, it makes perfect sense with our pattern blocks because I can place a trapezoid right over those 3. And we know that a trapezoid is a half. Please proceed to the next video in this lesson.